Okay, so problem 3 is called gearing up, and I'm not going to read the whole problem statement because it's pretty long, but pretty much the question asks to find the gear ratio for a given gear chain. So luckily it tells us how we can do this. It says to divide NB by NA, where NB is the output gear and NA is the input gear. And so the input gear is just the first, or the gear that comes first in the gear chain, and then NB is the one that comes second. So if we look at a drawing of this, this is the gear chain, the example when they give us 24 to 12. So we see 24 is the input gear and 12 is the output gear. So this is what it'll look like. And so the ratio for this would just be 12 divided by 14, which is 0.5. And that would be our gear ratio for this. And then it says if you want to do this for a bigger chain. Okay, if you want to do it for a bigger chain, it tells you how to do this too. It says you can just calculate multiple gears by multiplying the overall gear ratio with each pair. So if we were to add another gear to this gear chain, and if we add one more, and I think they say 18 in the example. Yep, 18. Then all we would do is take the ratio for this gear chain right here, which we already found to be 0.5. And then we want to multiply that by the next gear chain, or next gear pair, which is 12 and 18. So we do 18 divided by 12, which is 1.5. And then when we multiply those together, we get 0.75. So then if we want to do this as code, what we're going to want to do is look at each gear chain, or each gear pair in the whole chain, and find the ratio for each pair, and then just keep a running count so that we can get the whole ratio for the whole chain, and then so on. Okay, so if we want to do this in code, if we want to code it, so I'm going to use scanner. You can obviously use whatever input reader you like, but scanner is pretty easy for this problem. So it says we have multiple cases in each test set. So next page. Okay, so this will loop through each of the test cases. Then we want to take the whole gear chain. So we can do that by reading the next line and splitting it. So this will give us a string array of the entire gear chain, and we just need to remember to flush out the next line since we're using scanner. If you're not using scanner, you probably don't have to do that. Okay, then we want to go through the whole chain and look at each pair and then find the gear ratio for that. So if we look, there's two ways we can do this. We can either look at, we can start here, and then look at the next gear in the chain, and then just find the ratio for that. Or we can start here, look at the last ratio, the gear before it, and find the ratio there. So I'm gonna start from the second gear, and then look at the one before it, and then just do that for the whole chain. So for int k equals 1, listen. So this will look through the entire chain, starting from the first one, like here. And then we want to keep a running count of the ratio, so ratio equals 1. So right here, remember that you're doing it, since you're going to be dividing integers, it's always a good idea to use double, just so you don't have a concatenation issue. And then we can make the ratio 1 since we're going to be multiplying and dividing 1 doesn't really affect it, so that's a good number to start the ratio as. So then we can say ratio equals double dot parse double line at k double dot parse double, and then the gear right before it, and then we want to multiply that all by the ratio. So if we want to explain this, I use double dot parse double because if you could do integer dot parse int, since it does tell us that it's gonna that the chain is an integer, but you would just have to remember to typecast the integer to double so that you do so your number doesn't get concatenated when you divide. So I think it's just easier to parse it as a double. So this takes the first gear, and then this will look at the gear right before it, divide it, get the ratio, and then multiply that ratio for the pair by the ratio for the running ratio that we had for the chain. Okay, and then all we have to remember is it wants us to format it as 2.2 decimals, and then add this :1 to show that's a ratio. So we can use print formatting. So system.printf. I know we all love this from UIL, right? Mod .2f ratio. So if you don't know print formatting, all this does is going to take ratio, which is a double, and format it so that it has 2 decimal places. So like 3.057, or if we had like 3, that would become 3.0, just so that it has 2 decimal places. And then we just want to add the last part, the :1, that shows that it's a ratio. Alright, and if we run this, oh, that's awkward. Let's see. Oh, I have a extra. Oh, what is this? Right. That is very awkward. I think I am missing a parenthesis somewhere. Oh, I have been. Right. So when you're doing the problem, make sure you don't mess up your parentheses and add a hard bracket somewhere, because obviously that will make it wrong. But then if we submit this, then that'll give you the right answer, right? Good luck on the rest of the problems, and have fun.